Hello students, finally we have started our Physics 1 course on Monday, and we have already covered the topic units and measurements. I also have given you some homeworks, and now I'm going to illustrate how to solve some of the problems which I have given you. So, well, let's start with the first one. What are the dimensions of work? So the dimensions of three fundamental quantities, they are L. L is the dimension of length, and we also have T, which is the dimension of time, and M is the dimension of mass. Now, to find the dimensions of work, we have to express work in terms of fundamental quantities. Work is a derived quantity. So let's write A as F multiplied S, where F is the force which is acting on the particle, for example, and S is the distance that particle moves. So in this expression, S is length. It's a fundamental physical quantity. However, F again is a derived quantity. We have to express it in terms of fundamental quantities. So F, according to the Newton's second law, is equal to ma, where m is mass of the particle and a is the acceleration of the particle. Acceleration of the particle, we can write it as v divided by t. Dimensionally, v divided by t and a, they have the same dimensions, so that's why we can write it like this, multiplied S. Now you see M, T, S, they are all fundamental quantities. However, V is a derived quantity. So again, we write it as M. V is equal to S divided by divided by T, right? So it is S square divided by T square. So the dimensions of work is M, L2, and T minus 2. Well, now let's solve the problem 1.6. We have said that we can choose any independent three physical quantities as fundamental physical quantities, and all other physical quantities could be defined as derived physical quantities. In general, we said these three physical quantities are chosen as length, time, and mass. Now in this problem it says what would be the dimension of mass if we choose length, time, and force as fundamental physical quantities. So now let's say that the dimensions of L, it's again big L, and we also have the dimensions of T, and we also have the dimensions of F as well, big F. Let's say that big F is the dimension of F. Now, what is the dimension of mass? Again, we have to find such a relation that it should relate length time f and m, or m as a function of length, time, and mass. So let's start with the Newton's second law, and according to that, f is equal to m multiplied a. A is the acceleration of the particle, which is equal to v divided by t, or L divided by t square, right? Now from this equation we can find m as it is f t square divided by L. So dimensionally m is equal to f t square divided by L. So the dimensions of m, let's say this big M, is equal to the dimensions of f. Okay, let's write it here. It is f t square L minus 1. In the problem 10.10, if the energy of a particle E is given as alpha s square, then we have to find the dimensions of alpha, where s is the distance that particle has traveled. So to find the dimensions of alpha, first we have to know what is the dimensions of energy. Energy and work has the same dimensions. We will see it in the next lectures. So the dimensions of E is equal to, well, it was m L square t minus 2. So it's equal to dimensions of alpha multiplied s square, dimensions of s square, so it is L square, right? Well, this L square and this L square, they will cancel, so dimensions of alpha is equal to m t minus 2.